Okay. Hello, everyone, and welcome to our first of the two webinars about introduction of our new product, the AQSafe. I'm here, Omid Yousefi, the Research and Development Manager at Scentroid. And here I have with me Amir, our Engineering Manager, and we're super excited to introduce our new product, the AQSafe, as you can see here, to you today. So good morning, good afternoon, good evening, wherever you are in the world. Today's presentation, we will have some slides going on, and then as we go through the slides, here and there, we'll take a pause and we'll take all the questions. So if you have any questions, I encourage you to put them in the chat, and then we'll take them one by one as we go. So please put them up at any time that you want. So without further ado, I'm just gonna start sharing my screen, and I'm gonna get started.
All right, so let's introduce the AQSafe. All right, so let's do a quick overview. So here's the interface of the AQSafe. I'm not sure if you can see my mouse, but on the left side, you can see that this is the user interface on the actual AQSafe. So on the left side, you see all the sensors. These sensors can be chosen at the time of ordering. They're not fixed. So we have, in this case, we have a methane, total VOCs, a CO2, H2S, chlorine gas, ammonia, and formaldehyde. And on the right side, we have temperature, humidity, and barometric pressure, which is by default included in the AQSafe. And we also have particulate data, specifically PM1, 2.5, and 10. So one of the interesting features of the AQSafe is that you can see live readings, which you would see on the left screen. And if you were to press this average button, it'll give you averages, 1 hour averages, 8 hour averages, and 24-hour averages that you would see in this screen here. We are now showing 8 hour averages. And then we also have the settings button, which you can use to access your settings if you want to, for example, reconnect it to your network and check some other settings.
Yeah, great. Okay. Yeah, so before we jump into the spec, let me just show you the product over here. So this is the overall view of the product we have. So this is a ball mountable unit, and we're going to talk about that mounting later on. But basically, an overview of what this does is basically, this is a unit that you mount indoors to measure the indoor air quality. So much of the focus has been measuring outdoor air quality, but we find that the indoor air quality needs a lot more attention. So we developed this product as part of our new series. So in terms of the specs for this product, we can have about up to 11 sensors in this product, including 4 electrochemical sensors, 1 carbon dioxide sensor, 1 PID, methane, particulate matter, temperature, relative humidity, and barometric pressure, with the last 3 coming standard on all of the configurations. So we have various types of sensors included in this product that I'm going to go over. But we selected these types of product to be the most suitable for the measurement of the indoor air quality. So at the mere 860 grams, this is a very easy to use and mountable unit. And it has a built-in LCD, which Mir was just talking about, and that's over here. This is a touch screen, so users can configure everything about this product right over here on this touch screen. So as you may have noticed, this device only has 1 cord plugged into it, and that's the power cord. So in terms of the communication, this product communicates over Wi-Fi and wireless, also LoRa mesh. And I'm going to talk about the deployment later on, but that's the method of communication. In terms of the power, we just plug this to the wall outlet anywhere from 110 to 240 volts. And then the cloud server is included by default in this product. This unit has built-in alarms and multiple notification systems, as well as the temperature range of operating from 5 to 40 degrees. So we included our advanced sensors in this, meaning that we can perform health checks of these sensors on daily basis, and we can actually see if the sensor is not operating to its optimum condition. And of course, like all of our products, this comes with a 24 months of warranty, including all parts and sensors, and mounting as well. Since this is an indoor air quality device, we decided to make this as quiet as possible. So we have about only 7 dBA of noise, which is barely noticeable by the occupants. Now, in terms of the types of sensor, we researched a lot and saw that, okay, for indoor air quality, what is the best way of measuring certain pollutants for indoor air? And we selected these kind of methods, these 6 methods here for measurement of the pollutants. So for example, for particulate matter, we use the laser scatter technology, which we find it's very cost effective and very reasonable in terms of performance for indoor air quality. Especially for gases, we use mostly electrochemical sensors, which also we find are very cost effective. And we studied them a lot, and then we came up with algorithms to read these sensors as accurate as possible. And of course, we have more advanced technologies included here, depending on the type of sensors that you might want to measure. For example, the photoionization detection, the Geiger radiation counter even as well. So here's just a brief overview of the types of gases we can measure, but this is not a comprehensive list. I encourage you to visit our website for the full list of what gases we can measure.
Okay, so our AQSafe is very easy to install and operate. Installation is as simple as, well, we have two options for installation. There's a recessed back, so you can just hang it on the wall. And there's also, you can also screw it into the wall by removing the bottom cover. And it's as easy as just plugging it in and connecting it to your Wi-Fi network or your LoRa network, and it's ready to go.
Okay.
Okay. So here's an example of the deployment of our AQSafes. So we can have a bunch of AQSafes connected through a LoRa mesh network, which would work with another one of our products, the HVAC Warden, which communicates to a HVAC system. And that would communicate with your building management system through through a bunch of different communications. And in this case, we have it going through BACnet. And you'll also be able to see all your data live on the cloud server through your gateway, which would be sending to our sensor information management system website. And it would send to our server, and then you have a friendly user interface to be able to see all this data.
Yeah, so this is a cloud-based monitoring solution, meaning that once you have these devices deployed in your field of interest, then you can monitor all these devices on a single place on the cloud. And here's a quick snapshot of it that you can see here. We're going to go in detail a little bit more after this, but before diving deep into that, I'm just going to tell you that in terms of the alarms and notification, there are 3 levels of notification in this product, depending on the severity or the concentration of the pollutants in the environment. So first and foremost is the SMS and email notification system. So you can set that up on the cloud, and so whenever a threshold is reached, for example, CO2 levels reach, let's say about 800 ppm, which you can set customized in the settings, you'll get an SMS and email notification notifying you that the levels has been reached. On the next level, if you encounter a concentration a little higher, for example, you'll get an on-screen warning. So you can see on the right an example here, CO2 being shown in red. So the screen will show a warning as well. However, if the concentration even goes higher, you can also get an audible alarm system. So here in the device, we have audible alarm that will sound intermittently, telling you that, for example, the concentration is now exceeding the 3rd threshold that you set on the device. All of these, of course, are configurable per device and per customer and as per your needs, so you can configure them as you would like. Now, so we're going to talk a bit about our SIMS 2, which is our cloud-based solution for monitoring and analyzing all the data.
Mm-hmm. So you can access our Sims 2 from anywhere in the world, so as long as you have internet access. It's used for viewing live readings, historic readings, analyzing those readings, running diagnostics on your sensors, and various other things that you can do with it. It's provided, it comes as a package with our AQSafe, and it's available, you can use it with a mobile device or with your computer or laptop.
Yeah, so the SIMS 2 software is actually our second version of our SIMS, which was previously. In this new version, we have all new user interface. So we have all the tools you need on one single place. You can come here and see the historical data, and you can see which areas have been sampled, and you can also graph everything on the maps. So we have most of our products that send data to this server. And so, for example, for our drone, that you can actually see live maps of this as you collect data. But for indoor air quality, we have also a separate system for this, and I'm going to go over. Here you can see a snapshot of an example of what it looks like to analyze your data. So here you can see a 48-hour data being shown. So these plots show different gases and pollutants in the system. And on the same place, you have some advanced settings that you can play around with and set. So you can set the calibration parameters and the AQI values and all of that here, indexes. You can also adjust and select here.
Yeah, as well as you can also include, you'll be able to set up your alarms here as well for those SMS messages once a sensor has reached a threshold that you've set.
And those are per sensor, so you can configure different levels for each sensor as you would like. Yeah, so talking about that, the smart notification system, we've improved that a lot, and now you have a smart notification system. So in this way, we can have different gases and combination of them. For example, if CO is increasing, we can tell, for example, with other sensors in place, we can tell what's going on in the environment, and you can, based on that kind of information, you can set smart notification systems.
You can also, the good thing is, as well as the software will remind you if your unit is in need of calibration, it'll send you a reminder. If there's some, if you notice that, for example, if we notice that some of the sensors are misbehaving, we'll send a notification here as well.
Now, so what does it look like to set up multiple units in a big facility? Here we have an example of deployment in a hospital. So let's say in a hospital, we have different wards, for example, the maternity, isolation, ambulatory, and pharmacy. So in each of the wards, you can have multiple units deployed. So here you can see, for example, in the maternity ward, we have multiple units here. So you can name them, for example, room 402, room 403, and you can assign IDs per room. And you can come to this place, SIMS 2, and then monitor them all at once. And you can see which units or which rooms are experiencing certain changes in levels. And based on that, you can monitor and do what you want with them.
Yeah, there's no limit to the amount of AQSafes you can have in one building. And through our user interface, you can also monitor multiple places at one time.
Yeah, of course, different types of room have different requirements for air quality. So, for example, a clean room facility would need high restrictions on particulate matter. And so, for example, you can group them and then have different alarm settings for each type as well.
Yeah.
Now that I've shown you some of the overview of this product, now I'm going to show you a trial run that we've done showing how the device actually works. So we've done both in-home and in-office trials, and I'm going to go over some example data and show you actually what you can get from these devices. So the first is I'm going to over the placement of this in a home condominium unit and an apartment environment. Here you can see two data being shown. The yellow line on top, that is the carbon dioxide level, and the blue line on the bottom is the temperature of the environment. And I'm not sure if you can see here, but the graph starts here at 6 p.m. and then we come here about midnight over here. So what happened here is that at near midnight, the air conditioning inside the unit was turned on. And immediately from there, you can see the temperature drop corresponding to the air conditioning being turned on. And also the cyclic behavior of air conditioning, the thermostat basically working on and off to make this thing. That's why you see the cycles over here. So both the carbon dioxide levels are recirculating indoors, because the indoor air conditioning is just recirculation and there's no fresh air coming in. So the air conditioning was on throughout the night, and then at morning, the air conditioning was turned off again, and the temperatures you can see were slowly starting to rise back up to the ambient levels. Now, on this same graph, I just added the plot of the particulate matter 10, and that's this line. And you can see as soon as the AC turned on, overnight, you see a general trend of increasing trend of PM in the unit. And that is because of the movement of air is disturbing other particulates in the unit, and it increases them overnight. And as soon as the air conditioning is turned back off, the PM levels also drop back down as well. So what this tells us is that our indoor air quality systems, the HVAC units we have, for example, cannot be always as efficient as we think as they are in terms of filtering out the particulate matters that we breathe in. And here at 2 p.m., roughly here, you can see a little bit peak about the particulate matters, and that's corresponding to a use of a microwave at that time. Now, one more interesting thing about the apartment environment is the cooking and how it affects our indoor air quality, which we often overlook. So here you can see a plot of this humidity here. So, and the CO2 is the yellow line over here. So you can see at this point, there's a tiny bump here, and that corresponds to the time that individual just entered the room. And the sensor is very sensitive here, and actually can detect the presence of a human being in the room. So our breath produces CO2, and then from here, we can tell what the occupancy level of this place is. And we're going to talk about some school applications and how the air quality will, we can detect that, but this is just an example of one person being inside a room. But more interestingly, you can see here that there's a massive spike of particulate matter as well as humidity. And that corresponds to cooking. So here we were boiling pasta indoors, and so you can see the humidity was considerably increased. And then right about after that, we see that the levels were dropping right after the cooking was finished. Now, so what do these values mean? So, for example, we saw a PM go up to about 350 micrograms per meter cube. So what is that? Is that a good thing or a bad thing? So here we can see two of the standards that the EPA or ASHRAE have told us. For example, here you can see the upper limit of the CO2 is recommended to be about 1,000 ppm. And so for the indoor, we were pretty good at that time. So we were about like 400 and 500 ppm on the levels. For the PM, especially the PM 2.5, the recommended 24-hour average limit is about 65 micrograms per meter cube, which you can see was exceeded by significant level over here. So what this standard tells us is that we can have this 24-hour average recommendation exposure, but we don't really see this short-term exposure of high peaks, which will affect directly our health of an indoor air quality, which we find significant to be measured. This event 3 corresponds to the device being in our office. So this is actually data taken over 1 day. And here is about 9 a.m. where all the employees enter the building. And you can see the CO2 levels start rising as employees come in. And at the same time, we also see the PM levels also go up. And that's as a result of movement of air and the air conditioning as well being turned on. And near end of the day, so this is 6 p.m. The day before, so we can see the CO2 levels slowly dropping back down as employees left the place. Again, so here we can see the limit of the 65 micrograms per meter cube for the PMs. So we can maybe pause here, take some questions, and then we can move on with the second part of the presentation. Okay, so our first question comes from Long. They're saying, could the device create report of average days in average month to compare train changes in the environment?
Yes, we have some built-in automatic reporting. So you simply select the unit and the range that you want to report for, and it'll give you a report on the monthly data or even 6-month or 12-month data. And it'll auto-generate these reports for you.
Yeah. Oh, sorry, I missed the question earlier from George. The question says, can sensors be exchanged with different type of sensors after commissioning? While that's true, we do recommend that you order these with those sensors in mind, so we can deploy them, and then. But certainly, that's possible that we can do that.
Yeah, it is possible, and you can also changing the sensors after they've when it's time to change them after that 2-year or 3-year period. That's also easy to do, and you can do yourself.
Yeah, if you're thinking or questioning about like what types of sensors you would need for your place, you can always contact us, and we can give you recommendations based on what you're looking for to measure. The next question is, what about the calibration? How often? Who performs it? So all of our devices come standard with factory calibration. So at the time of ordering, before shipping the product out, we put them in specialized chambers that we built, and then we calibrate them as they would be in their real environment. So we calibrate that at the beginning, and then we have a sensor health check on these units that check the calibration settings over time. And if, for example, if there's a drop in sensitivity of the sensors, we can detect that, and we can do a recalibration to do that.
Mm-hmm. Recalibration, we recommend another product that we have, the GD600, for to simplify the calibration procedure. It'll allow you to do multi-point calibration on your sensors, and it'll even automate that for you.
The next question is, could the device export data in micrograms per meter cube? So you're referring to the particulate matters, and the answer to that is yes. So through our SIMS online database, you can export both raw and average data of any sensor that is there at any time.
You can also set you can also set it to, if you want to see ppb, ppm, or even micrograms per meter cube for your sensors. That's also an option.
Next question is from Prasad, and he's saying, can we use the equipment for outdoor monitoring? While you could use this in certain cases, we do not recommend using this for outdoor, because for outdoors we have a different products which is coming up called CTR. So stay tuned for that until we'll present that.
Yeah, our AQSafe doesn't have the necessary ratings for that outdoor use. Yeah.
Okay. Is there a pump inside the AQSafe? So with this new product, we decided not to use a pump, and we use our new air handling system that we developed in-house, which delivers a more constant airflow across the sensors, so meaning less noise. But if you're interested in connecting, let's say, a tube to this to monitor, let's say, an HVAC unit, that's something that we could look into. But we also have a different product for that, right?
Yeah.
So,
do we have internal memory or an SD card? Yes, we do. All of the data is also saved on an SD card inside of the unit, in case your network goes down and it doesn't come back up. There's all the data is saved there for retrieval.
Yeah. The next question is, can you calibrate the sensors yourself? And do you need a calibration gas for some of the electrochemical sensors? So the answer to that is both yes and no. I mean, if you have our GD600 unit, we can send you instructions on doing it yourselves. But we do recommend to have the calibration gas for the electrochemical sensors. But we can also perform calibration using co-location as well. Okay.
Is any security concerns using the cloud server? No, there's no security concerns. Our software developers use all the latest security measures. The data is secured. there's no security measures. There's it's password protected. So let me just quickly go over the different accounts that you can have on our. So there's an admin account which allows you to view and add users, remove users, and delete data. And then there's also a user account level where all they can do is just view data. And as the admin, you can create more accounts. You can delete accounts. You can set an account to only be active for a few hours, a few days, a few weeks. So there's no security concerns using our cloud server.
All right. So next question is, what about its communication? Maybe connect to. Yeah, so in terms of the communication, this device communicates over Wi-Fi by default, but we can also configure it to communicate over LoRa mesh. So the way it works, basically, once you mount the device in your location, you set up the Wi-Fi to your local Wi-Fi access point, or we can also have a gateway that configure all the units to send data into one place.
So if you do have like a LoRa network, it'll send all the data to a gateway, and then you can connect to the gateway using, for example, you can use Modbus, you can use BACnet, and connect to it from there to pull the data to your to the other instrument you're interested in communicating with.
Okay, next question.
That's answered already.
Yeah, okay, good. All right, since some gas are heavy and some light, depending on the sensors, what height should we fix the equipment? Yeah, so again, so in terms of what specific application you have in mind, then we can give you a recommendation on what height the unit should be mounted at. If, for example, you're in an environment where you have, for example, large levels of ammonia, then we recommend actually having both one unit on the top, one on the floor, because as you may know, ammonia, when it's dry, it's lighter than air and it rises up, but when it's ammonia with water absorption, it becomes heavier than air and then it goes down. So if you're really interested in monitoring that precisely, we recommend having 2 units for that application. But again, it's on case-by-case basis. So if you contact us, we can tell you exactly.
Okay, so the delivery time to Switzerland, good question. So it depends on the quantity of the order, but typically it's around 4 to 6 weeks.
Yeah, and that's also for anywhere else in the world. So
yeah, not specifically Switzerland. Yeah.
All right, so let's move on to our presentations. If you can switch back to our slideshow view, we're going to talk about a few applications of what the AQSafe can be used in. Okay, so the first very interesting application is for use in schools and universities. So as you may know, recently there's been a significant interest in monitoring the indoor air quality in schools. So in schools, we're typically interested in the particulate matters, the CO2 levels, and also the VOCs. Basically, we want to study and see how the occupancy of a room affects the outcome of the learnings, for example, or for example, transmission of disease and all of that. So this will be possible with our units there.
Okay, so for hospitals and other critical spaces, so some key things that you want to be interested in monitoring in a hospital, other critical spaces is pressure, carbon dioxide, organic compounds, oxygen levels, ozone levels, as well as dust levels. These are important when measuring. High carbon dioxides can cause some health issues. And obviously high dust is important for some critical patients.
Yeah, especially in the hospitals where we want to have like resolution at the room resolution level, so we can monitor the oxygen levels, the ozone levels, or especially the VOCs where all the cleaning is happening and all of that. So it's really important to monitor per room to monitor the patient's health. Another interesting application is the use in data centers. So these types of gases, for example, like chlorine and sulfur dioxide, are corrosive to the equipment in the data centers, and it's very critical to monitor these levels at all time and produce an alarm to provide mitigation at different times. So there are different standards about like what kind of gases and what certain limits are for them, them being damaging to the equipment. You can set this up in our unit and deploy them everywhere for that.
Especially some cleaning products, they give off different gases as they're being used. So it's very important to monitor those and make sure they don't exceed harmful levels for your electronics.
Yeah. Okay, next we have an application in agricultural facilities. So there's been a growing interest in indoor or like as you can see in the picture for gardening. We would want to be able to monitor the growth of these plants. And so with our device, you can actually monitor all these levels in this facility to monitor how the plants are performing and how they're doing, how much CO2 or oxygen exchange there is, and the humidity levels that you can keep at the optimum level, as well as temperature and other parameters. So for example, for this application, we can configure certain sensors that will give you a deeper information of what's going on in this environment and to increase the efficiency of the plants.
Exactly. What's important to note is that you can connect our AQSafes to your management system. So if you see, for example, temperature is too low or too high, you can connect it to your system and increase it based on that.
Yeah. Okay, so the next interesting application, which we had a lot of interest before, is about food and fruit and perishable items. So these items give off ethylene gas. So with our device, we can actually measure these. So if you have, for example, one of these units in your storage facility, you can actually tell what level these food items are at. So if they're close to being ripe, or like they have to be shipped, or like they have to be tossed out, all of that. So you can tell all of that based on these gas signatures that you can measure in the environment. Yeah. Okay, that brings us to the end of our presentations. If there are any questions, please post them in the chat. We'll be happy to answer them. So as last kind of point of view, let me just show you what the device looks like again. So the airflow actually is from this side. So there's a grill here with a filter, which is user replaceable. And let me just change my screen so you have a better view. So here's the device again. So again, the air intake is over here with a filter. And there's an outlet over here, which air comes out as well. And the PM sensor is actually at the very bottom, monitoring the PM levels in the air. So now in terms of the mounting, there are holes here for mounting. And yeah, so this is our product, and we're super excited to have introduced to you, and we're thankful that you guys are with us till now. There's 2 questions came in. So is this product patented? I'm not sure. Yeah.
No, it's not patented. We prefer to just keep everything in-house and not have that information available. So,
yeah. Next question is it US EPA approved? The answer to that is no. But we do perform calibration of this unit against US EPA certified units. So we have analyzers in-house that we perform co-location calibration with, and we make sure the performance is on par with those analyzers that we have. And especially that this is for indoor air quality, the operating conditions are pretty stable. So we expect a very good performance as we've seen in our testing as well.
And if you are interested in taking a look at this information about how our instrument compares to a US EPA device, feel free to email us and we'll happily send you those results.
Okay, with that, I'd like to thank you all.
Is there any other questions?
Yeah, let's see. Great. so two more questions just came in. They're about, are there bacterial or virus sensors? So currently there is no direct sensor that is measuring these viruses and bacteria directly. But with the sensors that we have on board, we can model basically the travel of these viruses and bacteria in the indoor air. For example, when you enter a room, your breath produces CO2, and we can, with many units indoors, we can kind of study and observe how these gases travel through our indoor air. And basically, for like, let's say you have a ventilation system, you can actually see where these are traveling to. And of course, we are working on different sensors here to be able to detect those particle levels to see and detect those as well. But it's something still we're looking at. Can you please share your emails? Yes, of course. Our contacts are all on the website, and you can go there and then contact us there, and we'll be glad to help you with that.
All right, yeah. Just as we just mentioned, as of right now, there's no standard for indoor air quality monitoring set by the US EPA. So it's something we're working with the US EPA to see if what's available and what we can. But definitely, our sensors are calibrated using US EPA methods.
Yeah. Okay, last question. Your marketing approach is to approach HVAC contractors or and customer direct. So we're aiming to have both as well. So and we have more of that. So like building managers or basically anything that you can think of. If you're part of like a management of the building, or if you're a direct end customer, we have solutions for both. Yeah.
All right. Is it possible to control air conditioning depending on the measurement? Yeah. So you can connect to your building management system directly through our AQSafe. We have a few different methods of doing that. Connecting to one AQSafe directly, or connecting through our gateway device. That's connected through either different protocols. So you can let us know what protocol you're interested in. We'll let you know if our unit supports it, but definitely Modbus and definitely BACnet.
Yeah, exactly. So especially with these units, you can actually see in real time if the CO2 levels rise beyond the comfortable level, or if the CO levels rise. You can definitely turn on the HVACs and basically adjust how much pressure also you want to take in the building. That's especially important in the winter times where efficiency matters. So you can adjust that dynamically to maximize the efficiency of your energy use. Yeah. Okay.
Another thing, if you're interested in seeing how our cloud server works, just feel free to email us. We'll give you a demo account where you can log in and view that information.
Yeah, great. So, okay. That's all the questions. All right. So, okay.
All right.
Okay, great. Oh, there's a final question. Okay. Okay. Is it possible to measure various VOC gases individually instead of total VOC? The answer to that is yes, but that requires that you would have two sensors that we can use for different gases. So each gas will have a different potential, and we can have customized sensors for your application.
Yeah, it definitely depends on the VOC. So let us know which ones you're interested in. We'll let you know if that's possible. Yeah.
Okay. Next question is, so you can also measure odor. Can you please give more info on that respect?
Yeah, so it depends. Yeah, we can definitely measure odor. The way we do that is we have, you would select the sensors that you want to measure. And what we do is we'd get some samples of the odor in your area. And we calculate the odor unit of that. And then we'd basically train our AQSafe based on that sample. And we put that training, it's our artificial intelligence learning, and we'll put that through, and then based on the sensor readings, it'll report odor.
Yeah, great. Okay, so if you have any more questions, please don't hesitate to reach us, and we'll be glad to answer any more you have. With that, I'd like to thank everyone for giving us your time here today, and we're happy that we shared with you. So thank you all, and have a great day or have a great evening.